Good afternoon everyone. Now we are ready to begin our session. Topic for this session is Quantum Computing Frameworks, IBM Qiskit, Google Search and Rigetti Forest, Fault-Tolerant Quantum Computing. In his continuation of his morning session, Mr. KARTHI GANESH-TOPIC will now shift focus to software and platform perspectives. He will guide participants through leading quantum development frameworks such as IBM Qiskit, Google Search and Rigetti Forest SDKs. This hands-on discussion will emphasize circuit transpilation, back-end selection and real hardware execution pipelines. We welcome you to deliver the lectures.
Good afternoon to all. So now the afternoon session, certainly not mathematics. Post lunch, discussing a technical details and physics concepts are heavy for you and me also. And one freedom I can give, if you feel sleepy, don't hesitate, sleep. You are going to realize what I am telling now. So this session is actually frameworks. As we discussed in the morning, when you start learning quantum computing, starting with the software is highly recommended for everyone except physicists and electrical electronics, EEE, ECE, EAE students. So when it comes to frameworks, morning, oh that morning is not there here. No problem. IBM, AWS, Rigetti, QERA. These are the 4 things we are going to see now. Ideally, it should have been a workshop kind of thing, but lot of these options need access to their cloud, which is money. You have to give your credit card. Considering that one, I did not ask the madam to enforce all students to create their account, because you have to enter your credit card. If misuse or you have not closed those accounts, it will cost financial, there will be a lot of financial loss. Considering that one, I decided let us keep this as a demo. So first let us start with IBM. So you have to go to IBM Qiskit documentation. I think the Tuesday session I showed this one, right? So if you go to that documentation, you will see Qiskit available as the Python library or C library. For your information, my production work means for client work I don't use Python. Not only me, many companies don't use Python for their production quality work. Then why we need Python? Most of the time Python is used to build proof of concept and prototype. So a Python developer will build the prototype and hand over to the software engineering team. They will translate that Python solution into HPC environment, high performance computing environment, which is predominantly C, C++, third one Fortran, not Java. It may be surprising to you, but this is what production systems. Production systems, Python and Java, they are all used for only web application. When it comes to, that is I want to make correction. You might have know, because Java solutions are there, they are all web applications. Website, e-commerce, web application, IoT, those things. But when it comes to scientific and engineering programs, we use C, C++, Fortran. Recently we started using a language called Julia. This is another popular language. So in IBM Qiskit you have the option to select Python and C. So obviously you will select Python. Under Qiskit API reference, select the version 2.2.1 or 2.1.2, whatever latest available, you are going to refer this one. Remember this one. If you are building something on IBM Qiskit, make sure you are going to this IBM website, have a 360-degree view of available documentation, which I am going to show now. IBM Qiskit documentation. This is the API reference I am referring. This API reference. Go here. If you come to Qiskit SDK, you will see Python and C. And this is available in the latest version. Older version, this Qiskit API will not show C version. But from the beginning, because I am working in Qiskit since 2016, from the beginning I worked in C only. Later I moved to Python only for teaching. So this will give you the clear picture. In the circuit construction, if you see the circuit library, you will see all gates, CS gate, CU gate. Remember I draw the matrix, I write the matrix, right? I can show those matrices here. For example, what is the matrix I wrote for P gate? 1, 0, 0, e power iota theta, right? Maybe here they may use lambda. No, here also they are using theta. This is the matrix for P gate. Like this, you can understand the matrix for all gates. For example, if you want to understand RX gate, that will be cos theta over to I minus I sin theta, I minus I theta minus I sin theta to cos theta 2. Like that it will come. Okay. So you can find all matrices for all gates. And it is not only that, you have to understand the hierarchy of this class or the object which is called API reference object model. That object model includes Qiskit circuit, circuit annotation, classical, library, random, and Qiskit info, CHI, CHOI, Clifford, all those information you can collect. Then in the transpilation, you have converters, tag circuit, all those things. Then primitives and providers, then visualization, then serialization, others. So, what is the recommendation from my side? Start with IBM Qiskit, that is much safer, because there are a lot of YouTube videos. If you want to learn on your own, you can learn from YouTube videos, and there is a detailed documentation like this. From here you can get all the API reference for those functions. The other option is this tutorial and these gates. If you go to the tutorial, these tutorials will give you a systematic way of learning those concepts. For example, it will start with the hello world, CSHS inequality, verifiable sampling algorithm, and it will go like this. Advanced technique for QA/OA. So like this it will go, it will teach you lot of concepts. So during the break, someone asked me how I can learn the mathematics and physics. So my recommendation is that when you are learning from IBM Qiskit documentation, you will open a tutorial like this. See, API reference is for reference, but before that you should get the programming idea, right? That you get it from this tutorial. From the tutorial, when you open up one particular model or one particular topic, advanced techniques for QA/OA, they will explain here. When you read this one, whatever mathematical concepts you are getting, try to explore and then learn them. Don't go deeper into that one. Learn them just what is what. Clear-cut guideline sheet. Spend less than 7 minutes. Don't go beyond 7 minutes for learning any concept. Within that 7 minutes, whatever you learn, that is enough. Now you may have a question, is that enough? No. That 7-minute cycle should be repeated 10 times or 5 times. You got the point? What I am recommending, don't spend more than 7 times at the one attempt. Repeat the attempts. Today spend 7 minutes on this CVA or cost function. Tomorrow or day after tomorrow spend another 7 minutes on the CVA. But don't spend 30 minutes on the day 1 on CVAR. It is not going to help you. The reason why it is not going to help you, here there are lot of technical terms, jargons. So you should start hearing those words frequently. Whether you understand or not, you should keep hearing, reading, discussing those things. That is where the community comes into picture. Either you can join our community, we have a community, KwantumG community, or else there are non-profit organizations, Quantum Computing India. Like that, there are many communities. Join those communities. In these communities, you will network with professionals, learners, teachers, and investors, mentors. You can find a lot of people. You can connect with them. Someone will help you. Someone will get help from you. That is how that community works. If you are a part of community, you will have that opportunity to hear the words or hear the discussion regularly. So that is how you have to learn the mathematical concepts. Because physics also. Because if you start learning as a systematic way, you should have a mentor. Why you need a mentor? Not to teach the concept, to stop you at the right depth. If you start going deeper into that one topic, you will get lost, which you don't need at all. You got the point? You are a computer science student exploring quantum computing using Python language with the IBM Qiskit. This is what your scope. Within this scope, if you want to learn the mathematical decomposition, only 3 or 4 techniques enough. You need not to sit down and then solve the mathematical problem. So your mentor will tell you, don't go deeper there, stop there. And there is one more thing in quantum computing. It is not about learning, it is about unlearning. This is a new word, unlearning, meaning that you have to forget some of the classical concepts. Then only you can understand quantum concepts. Because we have been studying classical concepts from childhood, some of the quantum concepts will not enter into our mind and heart. It will stop. It is like கவுத்து வச்ச பானை மாதிரி எவ்வளோ தண்ணியை ஊற்றினாலும் உள்ளே போவாது. You have to forget something, then only you will be able to learn them. These 2 things a mentor will help you. That is why you have to find a mentor to support your quantum journey. My recommendation, don't learn quantum computing without mentor. It is like going to trekking on a caves. See, trekking on a forest is something different, but trekking on a caves is very, very dangerous. Without guide you cannot go. You got the point? Because I don't know how many of you started studying, maybe madam is doing research, quantum cryptography. During the research, they will experience this one. They will start one topic, they don't understand, Google for it or ChatGPT for that. That will give some terms, they don't understand, do that one. After 12 minutes or 15 minutes, they don't know where are they. They will get lost. That is where you need a mentor. You understood? So, now coming back to this, where is that one? So, when you are learning that IBM Qiskit, this tutorial will give you the guided flow where you can learn Qiskit functions, all those things you can see. Okay? And good part is it will give you the program also. You see here, there are a lot of programs also. You can play around those programs using your Google Colab or your local Visual Studio Code. Okay. And these guides are another organized learning point. Here it will give you the various tools and their example. For example, in the visualization, if you see visualize the results, it will give you the detailed options, because yesterday I showed you some, Tuesday I showed you some Bloshpear, right? Bloshpear and then plot histogram. Those things it will be explained here. And you will see there is a color, all those things are available here. So, if you learn IBM Qiskit from IBM documentation, that will give you a clear picture. After that, you can learn from any of the YouTube channels. That is okay. But first-hand knowledge should come from official documentation. There is two reasons. One is the correct version you will select, because your laptop or your Google Colab, whatever version you have installed, that only you have to explore. But the YouTube video or any blog, they may have an older version because they have published a long time back. So that will be based on older version. So don't make the mistake. You will spend a lot of time and copy the code, run, then realize that the version is not compatible. Don't waste time like this. Okay? Now, with Qiskit, there is one challenge. In Qiskit, there are two components. One is Qiskit, other one is ecosystem. Originally, IBM introduced everything as one single set of solutions. How they did? Okay, let me go to let me take this one, because everything will be in one, 18, right? So, originally when IBM released their Qiskit system, they discussed like this. Terra is the foundation where the hardware and then control systems are there. On top of this, they get something called AER. AER is the air element. Then they had Ignis, then Aqua. Then third one is third-party applications. This is their structure, original structure. It will be something like this. Terra is your foundation. On top of Terra, you have AER, which is your simulator or connection to your real hardware. Aqua is the application. Ignis is the integration functions. That was the old one. But now IBM changed this to into a different system. Qiskit and ecosystem. Algorithms, machine learning, optimization, like many other capabilities are placed under ecosystem, and Qiskit has Qiskit, runtime and other essential part only. That is what current system. So you have to follow this one only. Then why I showed this one? Some of the literature, when you read, this reference will come. That time you have to remember this was the original architecture. Now it is moved to this building, the plug and play model kind of things. Right. Now let me show you. Ecosystem. Because ecosystem is very important in IBM Qiskit. For that you have to search IBM ecosystem, IBM Qiskit ecosystem. Because if you give normal ecosystem, IBM has lot of solutions, right? It will show all those ecosystems, that will be confusing. So search for IBM Qiskit ecosystem, that will give you the projects. You see here, Torch, this is PyTorch, the Python machine language package. Then Qiskit machine learning, the AER, remember I showed you that AER became a separate thing here. Qiskit finance, morning I was talking, right? Qiskit nature is for simulation. When you want to build simulating systems like weather forecasting system or digital twin or any other simulation material science, those things will use Qiskit nature. Then you have Penny Lane to Qiskit. This is very important plugin for connecting Penny Lane models with the Qiskit. Optimization, algorithms. Then I want to show one more thing. Azure Quantum. This Qiskit QEC, Qiskit error correction. This error correction is important for building fault tolerant systems. Like this, there are many solutions here. You can see here Kubernetes, Qiskit, serverless. I remember when IBM initially introduced, they have only that 4 components. All the functionalities will come under Aqua. Under Aqua, you have to import all the packages. That was very small initial days. But now the functionalities grow, so they decided let us keep everything into the Qiskit ecosystem. And what are they maintaining in Qiskit? You will see here. See Qiskit, Qiskit runtime, transpiler. These 3 things are there under Qiskit. All other are moved to Qiskit ecosystem. So if you want to run any program on IBM Qiskit, can I go to the demonstration now? Okay, right? I am going to use my command prompt. I am not going to use Google Colab because that will give you the different idea. See what you are seeing here. Okay, let me do this one. Let me start my command prompt. Okay, here one thing. How many of you know Linux? Raise your hand. 1, 2, 3. Okay, very good. How many of you know command prompt in Windows? 1, 2, 3, 4. Okay, thank you. I'm not sure whether you really know things and very shy about raising hand. But you are not shy, but really you don't raise your hand. God only have to save you. See, if you don't know Linux and if you don't know command prompt, you cannot claim that you are software engineers. You are all users, end users. End users only can ignore command prompt and Linux. But if you are a software engineer building solutions and in giving to customers, you should know Linux. It is really surprising to me. Less than 10% of the students have knowledge on Linux and command prompt. Sir, we have to do something about this one, sir. All of them must learn Linux without fail. I will talk to sir. We have to do something. Because without Linux knowledge, you cannot go to the industry. I myself rejected many applications because they don't know Linux. Of course, you are first year and second year students. It is acceptable. But when you move to third year and fourth year, you must know. So keep this in mind. When you are learning, important thing is Linux and Windows command prompt. But you start with the Windows command prompt because much easier because you are all using Windows system. Linux, you can do something called WSL. I will type here Windows subsystem. You are seeing here, right? Windows subsystem for Linux. You have to install this one in your Windows system. Then your Windows system, when you click WSL, it will work as a Linux box. There you can practice Linux commands. So take it seriously. There is no any compromise in Linux knowledge. I am not sure how many of you know this, but I am from industry. I know how we are hiring. So keep Linux as, when someone is asking, do you know Linux? You should not hesitate. You should confidently and then proudly tell, yes, I know Linux. Okay? Right. But as I told you, most of my production systems are Linux. I have my SSH, but that's all production systems. I cannot show in public forum here. So in Windows, whatever I am having, I am showing you. If you type dir env star, what are you seeing? envgat, envpy 311, 313, tk, vatv, something like this coming, right? Each one is called Python virtual environment. In Python language, there are multiple versions, right? 3.10, 3.11, 3.12, 3.13. And if some of my quantum solutions are working in 3.11 and some of my web applications are working on 3.10 and some of my IoT, Raspberry Pi, those kind of programs are working on 3.7 and all are in my one system. You understood the situation, right? In those situations, creating this kind of virtual environment will help me to keep my Python package, their versions as a separate component. What I can do, I can activate my 3.13. See, env py 313 / scripts / activate. What are you seeing here? env py 313. If I type Python -- version, you will see it is showing Python 3.13, correct? In the same system, if I do env py 311 scripts activate, and if I type Python -- version, it will show 3.11. What is the meaning? In my one laptop, I have 3.11, 3.13 also. You got the point? So, Python virtual environment is one of the important skills. So, what are the things you have to learn? Windows command prompt, Linux, Python virtual environment. And Python virtual environment is not only for quantum programming. Even if you are a machine learning programmer, AI/ML programmer, you will find this situation. TensorFlow, the latest version, is not compatible with many of the non-GPU laptop or GPU systems. So you have to install the older version 2.19. You just give pip install TensorFlow, it will install latest version that will not work in your laptop. So you have to select pip install TensorFlow equal to double quote 2.19.1 or 0. And I need another TensorFlow environment with the older version 2.12 for some reason. That time also we will create two virtual environment. You got the point? Virtual environment, very powerful concept for building production solutions. Cool. Right. Now, what I am going to do? So instead of wasting or instead of spending time on typing, I am going to take existing program. Yeah. Correct. This one I will show from here. Code DJ. When I run command code DJ, it will open up my Visual Studio Code. There is a program called Dye-Josha algorithm. DJ means Dye-Josha algorithm. It has, like yesterday what you have seen, or Tuesday what you have seen, it is importing these objects, then quantum register, classical register, then that what is called the Hadamard gate for Dye-Josha algorithm, and there is an actual circuit, then that execution result. Right? Now if I want to run this program, I have to go to my other command prompt. Python DJ. If I just run Python DJ, it will start working, it will show the circuit and then output. This is my circuit, this is my output. Understanding this DJ circuit, the output is beyond the scope of this discussion, because today I want to show you other environments, so I am not going to explain what is these things. Just I am showing how you can run IBM Qiskit programs in your local laptop. Tuesday I showed how to run in a Google Colab. Google Colab, again it is for non-IT people like physicists, mathematicians or any researchers who want to do those things. They can use Google Colab. But IT industry people, they have to configure all those things in their local laptop. That's why I am running on a local laptop. Is it clear? Any question on IBM Qiskit? No? But you have to get your hands dirty. Then only you will be able to repeat those things. While you are doing those kind of things, connect with your professors or faculties. They will think about whether they have to connect with me or not. We have to find out some way. And as I told you, you can connect with our community also. At the end of the session, I will share the community details there. And you can connect with me in LinkedIn also, such that you can build your network. Now I am moving to AWS. Is that okay? With AWS, it is lot more easier, but it is costly also. Let me log in into AWS console. Since you are first year, second year, you may not have access to that the cloud computing. It is, I think, in third year on. You are not studied cloud computing, right? Yeah, it is a part of cloud computing subject. So, in this AWS, I am going to log in as a root user. With the root user, my username and password, it is going to be and it will open in the Microsoft Authenticator. So I have to open my Microsoft Authenticator and then get the MFA code. I believe all of you know what is Microsoft Authenticator. If you don't know, please note it. ChatGPT. Ask the question to ChatGPT, that will explain. Microsoft Authenticator. Now you may start thinking, for one software platform we have to learn lot of new things, correct? இவ்வளோ கற்றுக்கிறது பேசாமல் சட்டி பானை தேய்க்க போயிடலாம் போல இருக்கு. ரைட், ஒரு டெக்னாலஜி எடுத்தோம்னு சொன்னால் அதில் கற்றுக்க வேண்டிய பாயிண்ட்ஸ் நிறையா வந்துக்கிட்டே இருக்கும். இப்படி தான் இருக்கும். நீங்கள் குவாண்டம் கிடையாது, ஈவன் நீங்கள் கம்ப்யூட்டர் இண்டஸ்ட்ரியில், அதாவது சாஃப்ட்வேர் இண்டஸ்ட்ரிக்கு போனாலும் இப்படி தான் இருக்கும். இதில் வந்து ஒரு டூல் கற்றுக்கிட்டோம், அதை வச்சுட்டு ப்ரொசீட் பண்ண முடியும், அந்த மாதிரி கிடையாது. எந்த இண்டஸ்ட்ரிக்கு போனாலும் இந்த சேலஞ்ச் இருக்கும். ஃபார்ச்சுனேட்லி யூ ஹேவ் ChatGPT ஆர் பெர்ப்ளெக்சிட்டி, தேர் ஆர் ஜென்ஐ டூல்ஸ், ரைட்? அங்கே போய் கொஸ்டின் கேட்டால் அது நல்லா சொல்லிக் கொடுக்கும், கற்றுக்கோ. வேறு வழி இல்லை. இது வந்து எப்படின்னா, புலிவாலை பிடிச்சிட்டிங்க மிஸ்டர் நல்ல தம்பி மாதிரி தான் இது. நீங்கள் சாஃப்ட்வேர் இண்டஸ்ட்ரின்னு முடிவு பண்ணிங்கன்னா லைஃப் லாங் லேர்னிங். அதே மாதிரி இந்த வெக்கம், மானம், சூடு, சொரண, ரோசம் அதெல்லாம் எதுவுமே இருக்கக்கூடாது. யாருக்கிட்ட வேணாலும் போய் கற்றுக்கிறது ரெடியாக இருக்கணும். புரியுதா? நவ் யூ ஹேவ் ChatGPT, கேட்டுக்கலாம். ஆனால் ChatGPT கரெக்டாக சொல்லாது. ஒரு சில இது வந்து அந்த இண்டஸ்ட்ரியில் இருக்கிறவங்களுக்கு தான் அது தப்பாக சொல்லுதுன்னு தெரியும். ஸோ ChatGPT மட்டுமே நம்பி நீங்கள் ஒரு வேலை செஞ்சீங்கன்னா நட்டாத்தில் விட்டுடுவாங்களே. நட்டாத்தில் விட்டுனா ஒரு சொல்யூஷன் பில்டு பண்ணி வச்சுருப்பீங்க, ஒரு சின்ன கரெக்ஷனுக்காக ChatGPTயில் ப்ராம்ப்ட் போட்டு அதை Ctrl+C Ctrl+V பூம், சொல்யூஷன் ஒர்க் பண்ணாது. அப்போ என்ன செய்யணும்? டீம் லீடுகிட்டையோ இல்லை கூட ஒர்க் பண்ணுற டீம் மெம்பர்கிட்டயோ போய் ஹெல்ப் கேட்கணும். அந்த எப்படி சொல்கிறது, மியூச்சுவலாக லேர்ன் பண்ணுற அந்த ஒரு மைண்ட் செட் இருக்கணும் அவங்களுக்கு. குவாண்டம்காக சொல்ல, நான் ஜென்ரல் கரியருக்காக சொல்கிறேன். அதே மாதிரி எதுக்கும் பயப்படக்கூடாது. ஃபியர் இஸ் தி கிரேட்டஸ்ட் சின். அப்படி கேள்விப்பட்டிருக்கீங்களா? உலகத்திலே பெரிய பாவம் என்ன தெரியுமா? பயப்படுறது தான். எத்தனை பேருக்கு தெரியும்னு தெரியல. இட் இஸ் த ப்ராவர்ப், ஃபியர் இஸ் தி கிரேட்டஸ்ட் சின். பயப்படக்கூடாது. எதுக்கு பயப்படணும்? அன்லஸ் யூ ஆர் டூயிங் சம் மிஸ்டேக், எதுக்கும் பயப்பட வேண்டிய அவசியம் இல்லை. தெரியாத கேட்க போகிறோம், அவ்வளோதானே. Now I will give you the road map for your career. First thing, you have to build a network. நெட்வொர்க் இல்லாமல் நீ எவ்வளோ பெரிய டெக்னிக்கல் பிஸ்தா இருந்தாலும் உன்னால் கரெக்டான வேலைக்கு போக முடியாது. நீ என்ன பண்ணுவேன்னா, உன்னோட தகுதிக்கு ஏர்ன் பண்ணாமல் ஏதோ கிடைச்சதை செய்கிறன்ற மாதிரி தான் செஞ்சுட்டு இருக்க. நீங்கள் நிறைய பேர் நியூஸ் படித்து பார்க்கலாம். 1 crore CTCல ஒருத்தன் வந்து கூகுளில் ஜாயின் பண்ணான் அப்படின்னு சொல்லிட்டு அவனோட ஹிஸ்டரியை நீங்கள் போய் பார்த்தீங்கன்னா he will have a humble beginning. எப்படி அந்த ஹம்பிள் பிகினிங்கில் இருக்கிற ஒரு ஸ்டூடெண்டால் அந்த மாதிரி ஹை லெவலுக்கு போக முடியுது? அந்த மாதிரி போன எல்லார்ட்டையும் நீங்கள் ஒரு விஷயம் என்ன பார்க்கலான்னா, அவங்க எங்கேயுமே கூச்சப்பட்டிருக்க மாட்டாங்க. இப்போ நான் கேட்டேன்னா எத்தனை பேருக்கு லினக்ஸ் தெரியும்னு, எத்தனை பேர் தெரிஞ்சுக்கிட்டே கையை தூக்காமல் இருந்தீங்க? I know more than 10 members did not raise your hand even though you know Linux. அதே மாதிரி கமாண்ட் ப்ராம்ப்ட்டுக்கும் you should first come out of that. தெரியும் தெரியாதது ஒரு எத்தனை பேர் இருந்தா என்ன, யார் பார்த்தா என்ன, நமக்கு என்ன? At the end of the day it is our hungry, we are going to eat for our hungry. அடுத்தவங்களுக்கு தெரியாது நம்மளுக்கு எவ்வளோ பசிக்குதுன்னு. You note the point? ஒரு விஷயம் புரிஞ்சுக்கோங்க, இந்த மாதிரி ஒரு பெரிய ஃப்ரேம் ஒரு பிளாட்ஃபார்மில் someone is asking question உங்களுக்கு தெரியுது, ஆனால் நம்ம கையை தூக்கினா பக்கத்தில் உள்ளவனை கேலி பண்ணணும்னு நினச்சிட்டு தூக்காமல் இருந்தீங்கன்னா இட் இஸ் த கிரேட்டஸ்ட் மிஸ்டேக் யூ ஆர் மேக்கிங். அட்லீஸ்ட் இதுக்கு மேலேயாவது அடுத்த எந்த மீட்டிங்கில் இருந்தாலும், இந்த மீட்டிங் கிடையாது, யூ ஆர் அட்டெண்டிங் சம் பப்ளிக் மீட்டிங், அங்கே கூட நீங்கள் தைரியமாக கையை தூக்கலாம். அடுத்த ஒரு நிமிஷத்தை நம்மளுக்கு ஒன்றும் கவலை கிடையாது. ஃபஸ்ட்டு அந்த இது வரணும் உங்களுக்கு. தட் இஸ் இம்பார்ட்டன்ட் ஸ்கில். எனக்கு தெரியும் ஆனால் நான் கையை தூக்கிறது தயக்கப்படுறேன் அப்படின்னு சொன்னால் தட் இஸ் த ஃபஸ்ட் திங் யூ ஹேவ் டு பிரேக். ஓகே, அதை பிரேக் பண்ணால் தான் யூ கேன் பில்ட் எ நெட்வொர்க். அந்த நெட்வொர்க்கை பில்டு பண்ணால் தான் யூ கேன் கெட் த ரைட் ரெகக்னேஷன் அண்ட் கரெக்ட் ரெமுனரேஷன் ஃபார் யுவர் ஸ்கில் செட். So other day I was emailing to Gopinath. Everyone is criticized me. On what basis you are writing to Gopinath? But I received email from him after 3 months. Planning a session. But if I அது தயங்கிட்டே இருந்தேன்னு வச்சுக்க, எனக்கு அந்த ஆப்பர்ச்சுனிட்டியே கிடைச்சிருக்கு. We have all the capacity to come to the limelight. முன்னாடி வந்து அதை செய்யறதுக்கு நம்மளுக்கு எல்லா தகுதியும் இருக்குது. தகுதியே இல்லைனாலும் உள்ள உன்னோட விருப்பப்பட்டது யார் அதை தடுக்க போகிறாங்க? ஃபர்ஸ்ட் பாயிண்ட், கம் அவுட் ஆஃப் தட். அந்த ஒரு பயந்துக்கிட்டு ஒரு பக்கத்தில் உள்ள என்ன சொல்லுவானோ அடுத்தவன் என்ன சொல்லுவானோ அந்த இதை விட்டு வெளியே வாங்க. எதனால் இதை நான் சொல்கிறேன்னா, இன் மை கரியர் ஐ ஒர்க்டு வித் லாட் ஆஃப் பீப்புள். ரொம்ப சூப்பராக பேசுவாங்க. அவன் பேசுகிறத கேட்டால் நாளைக்கு அந்த சொல்யூஷனை முடிச்சு கொடுத்துருவான்னு மாதிரி தோணும். முடிச்சுட்டு நாளைக்கு வந்து பார்த்தா ஒன்று கூட பண்ணியிருக்க மாட்டான். இல்லை அதை உனக்கு பண்ண மாட்டேன்னு சொல்லி தான் நானே முடிச்சிருந்துருப்பேன். ஏன்னா நான் உட்காந்து 2 மணி நேரத்து வேலை. ஸோ நல்லா பேசுகிறவன் வேலை செய்ய மாட்டான், வேலை செய்கிறவன் பேச மாட்டான். இவங்க 2 பேரையும் வச்சு மேய்க்கிறதுக்குள்ள நமக்கு போதும்னு ஆகிடும். அதுல நம்ம இங்கேருந்து வராம பாரு, நம்ம ஆளுங்க இருக்கானுங்க பாருங்க, ஷூ பேசுறதுக்கு காசு கொடுத்தா கூட பேச மாட்டான். அவனுக்கு நல்லா தெரியும். அதுதான் இங்க தெரியாம அவன் கதையா விடுவான். இவனுக்கு நல்லா தெரிஞ்சு பேச மாட்டான். ப்ளீஸ் கம் அவுட் ஆஃப் திஸ் ஒன். சரி, நீங்களாம் சென்னையில் இருக்கீங்க, யுவர் சிட்டி எக்ஸ்போசர் ரைட். நீங்களே இப்படி தயக்கப்பட்டீங்கன்னா இன்னும் சவுத்து போனால் பசங்களாம் எப்படி இருப்பாங்க நினச்சிப்பாரு. இண்டஸ்ட்ரியில் பார்த்தீங்கன்னா உட்காந்து வேலை செய்கிறாங்களாம் நம்ம ஆளுங்க தான். ஆனால் இன்க்ரிமெண்ட்டு ரெகக்னேஷனு ப்ரொமோஷன் வாங்கிட்டு போகிறதெல்லாம் பேசுகிறவன், நல்லா பேசுகிறவன், அதுலேயும் நம்ம ஆள் இருப்பான், அது வேற. பட் மெஜாரிட்டி ஆஃப் சவுத் இண்டியன் பீப்புள்ஸ் ஆர் குவைட். அதை விட்டு நீங்கள் வெளியே வரணும். அந்த குவைட் பயந்துக்கிட்டு இருக்கிறது, பப்ளிக் பிளேஸில் பேசுறது யோசனை பண்ணுறது, அடுத்தவன் நம்மளை ஏதாவது தப்பாக நினச்சிப்பானோ, வெளியே போனதுக்கப்புறம் பசங்க நம்மளை ஓட்டுவானுங்களோ, அந்த பயத்தை விட்டு வெளியே வா. நிறையா அப்படிதான் நடக்கும். நிறைய பேருக்கு வெளியே போனால் நம்மளை ஓட்டுவான், ஐயோ நம்ம கையை தூக்கிட்டோம், வெளியே போனால் நம்மளை ஓட்டுவானா, அதுக்கு பயந்துட்டே நிறைய பேர் கையை தூக்க மாட்டீங்க. ப்ளீஸ் கம் அவுட் ஆஃப் தட் ஷெல். அது ரொம்ப முக்கியம் ரைட். அந்த மாதிரி வந்தவங்க தான் அந்த 1 கோடி 2 கோடி பேக்கேஜில் போகிறவங்களாம். So if you want to do something extraordinary, you have to do something extraordinary now only. அப்போ ஆப்பர்ச்சுனிட்டி கிடைக்கவே கிடைக்காது, இப்போ பண்ணாதான் உனக்கு ஆப்பர்ச்சுனிட்டியே கிடைக்கும். Keep that in mind. Okay, right, we can continue quantum. Okay, now after logging in, if I go to bracket, oh sorry, I have to go to my console, AWS management console. Inside the it is taking lot of time here. Okay, I will it is taking lot of time. It's coming now. So in AWS management console, if you type bracket, yeah, it is already opened here, Amazon bracket. When I click the Amazon bracket, you will see dashboard, devices, notebook, hybrid job, quantum task, algorithm library, right? If you want to learn anything, you can learn from this algorithm library. If we go to our welcome to Amazon bracket, getting started, like this, all the tutorials, like how it is in IBM Qiskit, here also it has everything. But I want to show you the devices. Here you can see there are this first three: state vector, tensor network, density matrix. These three are simulators. And IonQ area, IonQ Forte, IonQ Forte Enterprise. These things are from IonQ. This is from IQM. And like this, you have a system from Qera and Rigetti. These are all quantum computers available under bracket platform. And here you will see something called show retired devices. If you click this show retired devices, you will see D-Wave and Oxford, Rigetti, Xanadu. All the systems are earlier they are available in Amazon bracket. So now you have the device, right? How you have to write the program? You have to go to this notebook. In the notebook, you have to create a notebook. Notebook is nothing but provisioning a EC2. EC2 means creating a server in your AWS cloud, and it is billable. For the demonstration what I am going to do now, I have to pay some money because I am provisioning GPU system. Under the GPU system I am going to build a quantum circuit. Because of that it will cost some money. See, I can create a standard notebook or advanced notebook. Advanced notebook will allow you to select more memory, processor speed, processor, GPU, memory, all those things I can configure there. When I click this create, it will ask for a name. For example, MIT 251030 and notebook inactivity. Okay, anyhow I will delete it. So when I click create, it will take at least 2 to 3 minutes to create that notebook. So as I told you, what is this notebook? This notebook is a Amazon server. It is a Ubuntu 24.04 server. It will, see, it is starting now. Under this one, it will have library, Python SDK, the developer guide. So if you want to learn, you can learn from these three link. Right? Let me go to the developer guide in a new tab because I don't want to disturb this one. So here they will explain what is Amazon bracket, how to import the statement, pip install, how to run, build, test, run, everything they will explain. So you can learn from this one, and it needs some of the existing cloud concept like this Boto 3. You can see here there is something called Boto 3. This Boto 3 is the library or API used to connect to S3 bucket. Now you know what is S3 bucket. S3 bucket is the storage option like OneDrive, Google Drive. We have Google Drive, right? Something like this, there is a storage provision in AWS that is called S3. So those connections you have to do here, all the guidelines will be given the same way how you are learning from IBM Qiskit, you can do that here. But now I think the notebook will be ready, I will come back here. So, still it is not ready. Let it run for some time. In the meantime, I will tell you the story. Story means why Amazon, we prefer Amazon. When we started, IBM Qiskit, it is only a superconducting quantum computer, right? Superconducting quantum computer has certain applications, but the trapped ion, photonics, neutral atom, they have different applications. If our problems is suitable for some other things, we cannot do it in IBM Qiskit. That time we will come to this AWS bracket. And when you are building quantum solutions for your client, the client don't know anything about quantum computing most of the time. But the client will have a research team who knows everything about quantum computing. So with the first hand understanding, if you are proceeding to that solution, you are going to face the biggest challenge. Because after the initial discussions, the client will connect you with their research team. Their research team predominantly mathematician and physicist. And if you go with your architecture and then software knowledge, they are going to eat your brain out. So, quantum companies used to hire physicists, mathematicians, software engineers. We won't hire software engineers alone. Even in my team, we have 2 physicists, 1 mechanical engineer, 1 doctor PhD in mathematics, then 2 software engineers. That is what my team consists of. Why? When you build the solution, we have to talk to the client team. The client team is going to discuss all the problems, their problems. So most of their problems involves physics and mathematics. That's why this one we need. Yeah, now it is ready. Let me open it. When you open the notebook, you will see something similar to Google Colab. Now you may think, if it is Google Colab, I would have done it in Google Colab itself. Why I have to spend money in AWS? You got the point, right? It's not loading. Again, it is Jupyter Lobby. You can see here it is Jupyter Lab only. And here you can see here URL Amazon bracket MIT 2510 notebook ES is blah 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 like this. So I can share this notebook with my other developers who can work in this notebook. That is one advantage working with the AWS bracket. So if you are building a team, the team members are going to work on this one. This will give you a platform to collaborate easily. But after building everything in Google, this Colab, what we will do, we will translate this into a Python file and then deploy this as an API and deploy this into a Ubuntu server and the client never had a chance to see the program. We won't deliver the Jupyter Lab as the deliverable to the client. Afternoon timing எப்படி 2 மணிக்கு ஆரம்பிச்சுட்டு 2 to 4 அப்புறம் 4:30 to 5:30 ஒர்க் ஷாப். உனக்கு தெரியுமா ஆஃப்டர்நூன் டைமிங் எப்படி? 4:30 to 5:30. Okay, another 5 to 10 minutes. Sir, break எத்தனை மணிக்கு கொடுக்கலாம் சார்? See, it is very slow. Maybe the Wi-Fi is slow. I don't know. Yeah, Wi-Fi is. Yes, sir. Okay, 3:15 you will get break. Right. Let us continue. It is not loading, but since we saw that Google Colab, that is the same way. But by default, the AWS bracket Python package will be imported automatically here. So you can use this one without any pip install, all those things. But if you want to run Pennyline on AWS, we have to do pip install Pennyline. Pennyline is necessary for running quantum machine learning code on your AWS bracket. Now I have a point to explain you bracket, right? So the meaning of the word bracket is, when I write like this, this is called zero ket, and the zero ket has a dual. The dual is called bra zero. So what is the meaning? This zero ket is nothing but a column vector and bra 0 is a row vector, but row vector of complex conjugate. Since the 0 I element is 0, complex conjugate also something like this. So this is called ket, this is called bra. That's why Amazon gave their endowment name as the bracket. So this is, you have to remember why Amazon bracket is called this name. Right. It is really, I don't know why it is taking a lot of time. But every minute it will cost me. So far whatever I have done now, it will cost 400 rupees just. So while it is running in service, for this much of time it will cost 400 rupees. Let me try to show you, because at least I want to show you how that AWS bracket will appear. Okay, so far we have reviewed IBM Qiskit and Amazon bracket. Post break we will discuss blockade, QRA blockade. Then I will explain what is the fault tolerant quantum computers. All these quantum computers whatever we are having now, these are the three things we are going to discuss. So IBM over, AWS over, QRA post break. So while it is loading, I want to explain a concept called QEC, quantum error correction. So when we compare classical and quantum, we used to discuss that classical is deterministic, quantum is probabilistic. Why quantum is called probabilistic? Because the psi ket equal to alpha 0 ket plus beta 1 ket. Alpha and beta are probability. And because of this probability, when you perform some operation in quantum computer, it will give different result for each execution. That's why when you run your circuit, you are seeing a histogram showing this output for this number of time, this output is some other number of time, which means the probabilistic nature of quantum computing is introducing lot of error. And apart from that, not only is this probabilistic in nature, the quantum hardware also fragile, handle with care. It is very risky. Even a slightest radiation, vibration, any environmental change will affect qubits. You won't believe me, initial days IBM quantum computers were get affected by sun flares. Where is sun flare is happening? It is happening in sun. That will affect the qubit in earth. Initial days. Because the qubit which is built on superconducting technology need to go to minus 273 degrees Celsius. When we are confining a quantum system up to that superconducting stage, even the slightest variation in temperature will impact it. Because already we are going to minus 273 degrees Celsius. And if sun flare happens in sun, that is going to impact the temperature in earth. Of course, human cannot feel it, but some system which is operating at minus 273 degrees Celsius will feel it. You won't believe it. That is the level of sophistication we need to build quantum systems. But now they found various methods to protect. Now it is not that much. So, what is the meaning of this quantum error correction and how we are building a useful system? That is what our next session. Oh, finally it came. Okay, let me show finally. Oh my God. See, when your AWS bracket is ready, it will show a Google Colab kind of interface. And here, if you see the bracket algorithm, it will show lot of algorithms. Quantum principal component analysis, all those things are available. It is really very beautiful platform. Initial days when I start learning this one, this is really helpful for me to learn. You can see Bell's inequality, Benson-Vazirani, Dye-Josha, Groyer search, all those things are available. It is really, AWS bracket is really a good platform to start with. If you are able to spend 7,000 to 10,000 per month. Because this AWS will cost you. If you create a notebook, just now I told you, the moment what I am showing now, that will cost me around 400 rupees. Because after this session I will close it. Within this much of time they will charge that much. So when you are using for your learning purpose per month, whenever you are open, you are working on some time, that will cost. So we have to allocate a budget of 10,000 rupees. If you are going to use AWS bracket. It is not cheap. So what we will do, we need AWS but not in the notebooks. Then what we will do, remember the Qiskit how I am doing, pip install Qiskit in my local laptop. Like this I can do pip install bracket. Then do everything in my local system. When I want to connect to my AWS bracket, I have to use something called the device identification. So each device you call something called ARN. When I click, for example, when I click on a device, for example, Qara Aquila. If I select Qara Aquila, it will have this device ARN. I have to use this device ARN in my program, which I am running in my local laptop. Then that will connect to this system. That time, AWS will charge for the QPU cost, not for the notebook cost. See, there are two costs involved. One is notebook cost, other one is QPU cost. Whether you run it on notebook or in your local laptop, you have to pay for your QPU. Only notebook cost you can save, around 17,000 you can save. But quantum computer cost, it will go to 40,000, 50,000, something like that. There are bills, 8 lakhs, 16 lakhs also there are bills. Of course, that will be paid by our client, not by us, right? Because when we are building solution for client, the client will pay for us. So we never worried about working that much of time. All those things will be paid by client. Now you may think, 18 lakhs will they pay? Think about the hedge fund or the pension fund in Europe. They are going to earn more money. They are going to earn crores. Then obviously they will spend in lakhs. That is what business. That's what I told you. Right? Any question? Can I close my notebook? At least I can save another 50 rupees or 100 rupees. Don't worry. It is meaningless. You can't going to practice anything. So keeping that as a spending money unnecessarily, it waste. So I will stop like this. After stopping, I will delete it. You won't believe me. 2023 in one college in Hyderabad, we have conducted the AWS training. It was on Saturday. I finished my session, and after finishing my session, the administrator revoked my admin permission. I am returning from Hyderabad to Bengaluru. I am driving self-driving car. I am coming. Just out of curiosity, I am checking the statement. I am seeing the bill is running. That administrator, he has to go to Kerala. Out of urgency, he forgot to close all the notebooks and then he started travel to Hyderabad. Kerala. When he reached Kerala, when I reached Bengaluru, the bill went to 10 lakhs. Because 73 students activated. That batch was 73 students who opened their notebook. There are 73 books are open and there are algorithms running on those things. Those algorithms accessing QPUs. No, then we talked to AWS. I had some friends in AWS and then can explain to them, then put into under the another account, then adjusted that one. So the college paid 5 lakhs. So these things will happen. That's why we should be very careful when we are using quantum systems in cloud. Of course, that college is wealthy college. 5 lakhs is not a money for them. I cannot tell the names and all. Any other question? No, right? Break. I am ready to give break. Sir, can I give break now? Yeah, okay, you can go for break. Have a look into that book. That will give you what I refer. Those two books. One is 17 equations that changed the world. Other one is quantum information and quantum computation by Michael and Nielsen. Slip ஆகுதுல ரொம்ப ரிஸ்கியா இருக்கு டைல்ஸ். Right. So now I am going to delete this notebook. Of course I stopped, it won't start building, but still for safety I would like to delete it. Okay, right. Next one is blockade. Q era. Q era, not Quora, Q era. This is the company name what I am referring. This Q era is the neutral atom based quantum computing organization. Their computer systems are called Aquila, Aquela, and their simulator name is Blockade. This is what their website, and their platform is called Blockade. So originally QERA released their framework as their platform as a Julia solution, not a Python solution. That was their original version. But later, on popular demand, most of the people don't know Julia, so they have released Python also. So if we go to the platform, it's taking a lot of time. So if you recall the working principle of neutral atom systems, they are based on an atom called Rydberg atom. These Rydberg atoms are built on a UHV, ultra high vacuum lattice. Lattice means array. So the ultra high vacuum lattice has a property of behaving with the quantum mechanics behavior like a lattice kind of thing. There will be energy level of those. Actually, it is individual energy level of molecules in that UHV. So that individual energy levels will be in high, low, which is 0 ket, 1 ket, in between. This is measured with the help of laser and also microwave. So the neutral atom systems can operate in lesser temperature, meaning that minus 100 temperature also, minus 100 degree temperature also it will work. It doesn't need superconducting temperature like minus 273 degree. So neutral atom systems are little bit less costly compared to superconducting, but they don't have all native gates. So performance wise there may be little bit difference, but they are suitable for some of these machine learning problems and simulation problem and optimization problem. The reason is that these Rydberg atoms have a behavior called Rabi oscillation. So the word Rabi oscillation, right? That oscillation can be used to simulate the natural behavior. There is a machine learning model called reservoir computing. There is a model called reservoir computer. Reservoir computing. This reservoir computing is a machine learning model, AIML model. This reservoir computing can be considered as inverted, not inverted, rotated neural networks. What is a neural network? If you remember, neural networks are written like this, right? But this one is like this. Like this. So, and they are not fully connected, they are partially connected. But normal neural networks are fully connected. That is the difference between reservoir computing and neural network. So reservoir computing is nothing but a partially connected or sparse neural network. Sparse neural network means there are many connections are missing. So this kind of computing can be achieved with the help of Rydberg atom and Rabi oscillation. That is the purpose. Why we need QRA? Not only QRA, any neutral atom systems. But not only for reservoir computing, they have potential to solve many other problems. That is what I want to show here, but it is not opening up. No problem, I will show with my presentation. This slide what I am showing now, this will explain various types of quantum hardware and their working principle in detail. So when I say the superconducting quantum computers, you can see it has 2 niobium atom, 1 aluminum atom. Similarly, when I say this is ion trap, where the calcium ions are trapped between 4 electrodes. One is horizontal, 2 are horizontal electrodes, 2 are vertical electrodes. So if the ion fluorescence is towards horizontal, that is 0 ket, towards vertical 1 ket, in between it is the psi ket, and that is how this trapped ion is working. And this is for photonic qubits, where a single photon source through this modulator will be controlled by this optical waveguide, and that effect will be read from this resonator. That is what photonic qubit. And this is what neutral atom. Remember I told ultra high vacuum UHV. This UHV is what you are seeing here. Recently means 2 weeks ago I read one article. MIT is working on something called quantum vacuum thrust. Quantum vacuum thrust. What is the quantum vacuum thrust? When you are creating a vacuum between 2 plates by closing them very close, such that they are like attached to each other, but they can't attach because they are 2 separate items, right? There will be a vacuum between these 2 plates, right? When we are creating that kind of vacuum, that vacuum is not real vacuum. What scientists recently found out that whatever we are thinking vacuum, it is not real vacuum. It is called quantum vacuum, meaning that the quantum mechanical behavior is still there. That quantum vacuum will cause a repulsive action at the quantum level, subatomic scale level. This repulsion can be used to build a movement. That movement can be used to build rocket controlling systems in the absence of gravity, meaning that the International Space Station, in International Space Station, when they want to move some of the device outside that International Space Station, then come back, as of now they are using very costly fuel to move around and then come back, because there is no gravity there, right? So that movement is controlled by more fine-tuned control in the absence of gravity. But scientists has found out that this quantum thrust can be used to control those vehicles. And another important discovery is that, or invention is that, it is just exploration. It can be used to build batteries, quantum batteries. You will be surprised to see. I have a very basic question. You have 6000 mAh battery, 10,000 mAh battery. Which battery will take more time to charge? We can tell 10,000 mAh battery, right? But in case of quantum, if it is a quantum battery, 10,000 mAh battery will take less time compared to this 6000 mAh battery. Again, look like magic, right? How you can justify this behavior? Larger capacity is reducing your charging time. For that, the scientists are explaining that, do you know photosynthesis process? All of you know photosynthesis process, right? Smaller leaf will generate less number of photos that process. A bigger leaf will generate more, which means the quantum battery is working based on the photosynthesis process. Because of that, a larger battery size will get charged very fast, because it is like very big leaf getting energy from photons. Because of that, it will charge your quantum battery faster than a smaller battery which is a smaller area. Not only this, if you start exploring quantum technology, I am not telling quantum computing, quantum technology, you will surprise to see lot of things. Just I am checking in the library, you have books on quantum chemistry, quantum mechanics, there are a lot of good books in the library. I thought that I could sit here and then read those books. So start exploring and don't limit only quantum computing. If you have more idea, you can start exploring multiple ideas. So this will give you all the quantum platforms. Now coming back to the Q era, I believe now it will open. It's not opening now. This application, Go design offered from Q era is not only for Q era. Most of the quantum companies started offering application code design. Under this application code design, what they are offering, you come up with a solution, use our system, use our scientist, build the solution, let us market that as a co-brand, meaning that both QRA and your company can market the solution. This kind of offer is not available in classical world. In classical world, Microsoft, these companies are offering gold partner, silver partner, like that, right? Those partners are different category. But application Go design is something more higher privilege. So these kind of opportunities also available in quantum computing. That particularly the QRA and another company is Fujitsu. Fujitsu also building quantum computers. And in that system also we can go application code design can be done. And this is the race to qubit, which technology is going to build more number of qubits. And these systems are called NISQ era quantum systems. Whatever systems we are discussing now, They are called, oh, it is not mentioned here. I will write it. NISQ, noisy intermediate scale quantum. Why it is noisy? Because it is operating at the subatomic scale, and any environmental disturbance will affect the qubit operations, and reducing the noise is not under our control. That is the reason why the current systems are using quantum error correction. This quantum error correction, like logical qubits and Shor's algorithm, Alexei Kitaev, Sergey Bravio, and this one, the final now grass code is explored. Using these kind of codes, they are trying to reduce the error caused by noise. So, if we reduce most of the noise, we will reach a system called fault tolerant quantum. Fault tolerant quantum is the ideal quantum system, where we can confidently use quantum systems for solving our problem. To build a production quality system, we need minimum 40,000 qubits. But what is the qubit count so far achieved? 1000. So what is, oops. What are you seeing? IBM has 1121 qubit, Atom Computing has 1180, D-Wave has only 5000 qubits, but these are all Yana Pasiki Solapuri Mari. Because industry needs 1 lakh qubit, but the companies are able to build only thousands. Where is the difference? 1000 to 1 lakh. At least 40,000 qubits we need. But we are not seeing the nearest timeline. That is where the morning, remember I told you generation 2018 to 2028. IBM has released their roadmap at when they are releasing their advanced quantum processors. They are telling 2028 they will be able to release 10,000 qubit noisy NISQ era quantum processor. But their fault tolerant is still 1000 only. So, Atom Computing 1100, and remember I told you Caltech they built 6000 qubits. So, the research is going on. See, when I started exploring quantum computing 20 years back, I thought that it will take minimum 30 years. But what I am realizing now, the industry is able to achieve those within 25 years. We are 5 years advanced compared to the industry prediction.